Hello viewers, in today's class we are going to discuss one important problem from limits and continuity, right? So here we are given a function f of x is equal to x minus 1 times 10 pi x over 2 when x is not equal to 1 and lambda pi when x is equal to 1. Now this function is given to be continuous at x equal to 1 and we have to find the value of the constant lambda, right? Okay, so let us start. Now we know that a function is said to be continuous if the left hand limit exists and finite, and right hand limit also exists and finite, and both are equal, right? And moreover, these two limits are equal to the value of the function at that given point, right? So LHL, that is left hand limit, should be equal to RHL, that is right hand limit, that is equal to the value of the function at x equal to 1, right? So this is the condition for continuity of a function at a given point. Now here we know that the value of f of 1 when x is equal to 1, the value of the function is given as lambda times pi, and we need to find the left hand limit and the right hand limit, right? Okay, so now let us first calculate the left hand limit. Now LHL is equal to limit x tends to 1 minus, here the negative sign indicates that we are finding the left hand limit, and here we have f of x, right? So this is limit x tends to 1 minus, and for fx we can write the function x minus 1 tan pi x over 2, right? So here x is approaching towards 1 from the left hand side, that is for all values of x which are less than 1, right? So here we'll make use of one substitution, that is we'll substitute x is equal to 1 minus h, and h is a positive quantity and it is very small, right? So when x tends to 1, then h tends to 0, right? So this expression now it takes the form limit h tends to 0, and for this x we can write 1 minus h. Here we have minus 1 and we have tan pi by 2, and for x we can write 1 minus h, right? Now we can simplify it. This is limit h tends to 0, 1 and 1 get cancelled, so we are left with minus h, and here we have tan pi by 2 minus pi h over 2, right? Okay, so now here we'll use the trigonometric result, that is tan pi by 2 minus theta is equal to cot theta, right? So this expression is limit h tends to 0, here we have minus h, and we have cot pi h over 2. For theta we have pi h over 2, right? Okay, so now here we can write this expression as limit h tends to 0 minus h over tan pi h over 2, right? Because cot theta is equal to 1 over tan theta, right? Okay, now here we can again make a substitution, and let me substitute t is equal to pi h over 2, right? So we'll substitute t is equal to pi h over 2, because here when h tends to 0, obviously t tends to 0, right? So the left hand limit now becomes limit t tends to 0, and here we have a negative sign, and for h we can write 2t over pi, right? So here we can write 2t over pi, and in the denominator we can write tan t, right? Okay, so now this expression can be written as taking minus 2 over pi here, and then we can write limit t tends to 0, and we have t over tan of t, right? Now we know the famous limit which says that limit theta tends to 0, theta over tan theta is equal to 1, right? So this limit is equal to 1, so we are left with minus 2 over pi multiplied 1, that is minus 2 over pi, right? So the left hand limit of this function at x equal to 1 is minus 2 over pi. Now in a similar fashion we can calculate the right hand limit. Now viewers, let us find out the right hand limit. So the expression for right hand limit is limit x tends to 1, and here we have the positive sign and fx, right? So the positive sign indicates that x approaches from right towards 1. So we have limit x tends to 1 plus, and for fx we have x minus 1 tan pi x over 2, right? So now we'll substitute x is equal to 1 plus h, and here h is a very small quantity, but h is greater than 0, right? So when x tends to 1, then obviously h tends to 0, right? So let us make the substitution here. So we have right hand limit is equal to limit h tends to 0. For this x we can write 1 plus h minus 1, and we have tan pi by 2, and for x we can write 1 plus h, right? So now we can simplify it. This one and this one get cancelled, so we have limit h tends to 0. Here we have h, and we have tan pi by 2 plus pi h over 2, right? So now we can make use of the trigonometric formula, that is tan pi by 2 plus theta is equal to minus cot theta, right? Where theta is pi h over 2. So now we have limit h tends to 0. Here we have h, and we have minus tan pi h over 2. Sorry, here we have cot, so we have cot pi h over 2, right? So now this can be written as limit h tends to 0 minus h over tan pi h over 2. Again, cot theta is equal to 1 over tan theta, right? Now here again we'll make use of the substitution method, and let us substitute t is equal to pi h over 2, right? So when t is equal to pi h over 2 and h tends to 0, so obviously t tends to 0, right? And the value of h is 2t over pi. So this limit can be written as limit t tends to 0, and we have minus, then the value of h is 2t over pi, and here we have tan t, right? Now this can be written as minus 2 over pi, because this is a constant, we can take it outside this limit sign. So we have limit t tends to 0, and this is t over tan t, right? Now again we can make use of the result, that is limit theta tends to 0, theta over tan theta is equal to 1, right? So this limit is equal to 1, so the right hand limit is equal to minus 2 over pi multiplied 1, that is minus 2 over pi, right? So now let us again come to this relation. So we have obtained the value of left hand limit as minus 2 over pi. So let us substitute it here. So we have minus 2 over pi. Right hand limit is also equal to minus 2 over pi, and f of 1 is given as lambda times pi, right? So now from here we have the relation minus 2 over pi is equal to lambda pi, that is equal to lambda is equal to minus 2 over pi multiplied pi, that is minus 2 over pi square, right? So the value of lambda is minus 2 over pi square, right? So viewers, if this function f of x is continuous at x equal to 1, then the value of lambda is minus 2 over pi square.